Trig Functions by Sebastian Hernandez. What are trig functions? Trig functions are the mathematical functions that relate to the angle of a right triangle to its side lengths. The six main trig functions are sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, tangent theta equals opposite over adjacent, cosecant theta equals hypotenuse over opposite, secant theta equals hypotenuse over adjacent, and cotangent theta equals adjacent over opposite. Cosecant theta is the reciprocal of sine, secant theta is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Inverse functions. For tangent, cosine, and sine, their inverses are arctan, arccos, and arcsine. They do the reverse, giving you an angle when you provide a side ratio, written as tan to the negative 1, cosine to the negative 1, and sine to the negative 1. Secant, cosecant, and cotangent also have inverses, secant to the negative 1, cosecant to the negative 1, and cotangent to the negative 1. In this problem, we see secant x equals 5 over 4. What is the value of x? What we would do first is rewrite the equation, making the equation be 1 over cosine x equals 5 over 4, as the secant is the reciprocal of cosine. Then we'd basically flip the equation, rewriting the equation to be cosine x equals 4 over 5. We can then use the inverse of cosine and get the answer, x being around 36.87 degrees. We can check if we are right by using the inverse of secant, which also ends up in x equaling around 36.87 degrees. For the tangent graph, we see two vertical asymptotes located at negative pi over 2 and pi over 2. The tan graph repeats over and over, so we see multiple other lines and multiple other vertical asymptotes. The range is all real numbers, but the domain is all real numbers except for odd multiples of pi over 2. One thing to know is that tan measures the ratio of the y-coordinate to the x-coordinate. The inverse of tan is the exact same, but just the inverse, having the domain and range switched. And now instead of having vertical asymptotes, it has horizontal asymptotes, still located at the same points though. For the cot graph, instead of increasing like the tan graph, it is decreasing. The domain is different, now being all real numbers but integer multiples of pi. The range stays the same, though still being all real numbers. The inverse of cot is like the inverse of tan, also having its domain and range switched. And this also has its vertical asymptotes now becoming horizontal asymptotes, also still located at the same points though. For the cosine and sine graphs, they look exactly the same, apart from the fact that the cosine graph has a y-intercept at 1 and the sine graph has a y-intercept at 0. Cosine measures the horizontal distance from the y-axis, and sine measures the vertical distance from the x-axis. They both have the same domain of all real numbers and the same range of all numbers greater than or equal to negative 1, but less than or equal to 1. The inverses are slightly different though, with the cosine graph starting at 1 and the sine graph starting at negative 1. They shared the same domain of all numbers greater than or equal to negative 1 and less than or equal to 1. The range for the inverse of cosine is all numbers greater than or equal to 0, but less than or equal to pi. The range of the inverse of sine is all numbers greater than or equal to negative pi over 2, but less than or equal to pi over 2. For cosecant and secant, their graphs seem like parabolas, but they aren't due to vertical asymptotes. An easy way to identify which graph is which is knowing that the secant graph has a y-intercept and the cosecant graph doesn't have a y-intercept. They both share the same range of all numbers less than or equal to negative 1, union all numbers greater than or equal to 1. The domain for cosecant is all numbers but integer multiples of pi, while the domain of secant is all numbers but odd multiples of pi over 2. For the cosecant and secant inverse graphs, it gets a little more complicated, but you can still tell which is which by knowing that the secant graph has an x-intercept while the cosecant graph doesn't. These inverse graphs share the same domain of all numbers less than or equal to negative 1, union all numbers greater than or equal to 1. The range for the inverse of cosecant is all numbers equal to or greater than negative pi over 2 but less than 0, union to all numbers greater than 0 but less than or equal to pi over 2. The range for the inverse of secant is all numbers greater than or equal to 0 but less than pi over 2, union all numbers greater than pi over 2 but less than or equal to pi. Thanks for watching.